Hello everyone. Today I'll explain you the topic of flow of heat. Without wasting much time, let's get started. So, before moving on to the chapter, let's read some of the major properties of heat. So, one of the major property is heat flows from hot end to cold end. So, yeah, let us understand this property more with the help of this example. So, in this example, there is a glass tumbler with hot water taken in it, and a metal spoon is put in it, and a person is holding it. So, we can say that this is a hot end and this is a cold end, obviously. So, according to the property, the heat will transfer from the hot water to the spoon, and that's what happens over here in this case. After some time we would be uncomfortable to hold the spoon much more anymore because it would be heated now, and it would be really uncomfortable to hold it. So let's move on to the chapter. So there are three methods of transfer of heat: conduction, convection, and radiation. All these three methods of transfer of heat satisfy this property. And there's one more property though, that says that if two objects have the same temperature, then the flow of heat cannot occur. Obviously, we can understand this that property from this property only, because hot end have the more temperature and cold end have less temperature. So they are different temperatures like that. Okay, let's move on. So now let us study about conduction in detail. Conduction is a process of heat transfer in which heat travels from hot to cold end. I told you, all these three methods of heat follow this property. But the special thing about conduction is that it happens through a solid medium. So let us understand conduction with the help of the example. Here, a stand is there, and a metal rod is attached to it. And there is a candle which is heating a metal rod. And the and some thumb pins are attached to the metal rod with the help of wax. Now we can say this is hot end and this is cold end. So obviously the metal rod acts as a solid medium. So the transfer of heat would be from the candle to the pins. And when the heat is reaching to the cold end, the wax will melt because of the heat transfer, and the pins will fall down one by one, and that's it. And conduction takes place over here. Now let us learn about conductors and insulators of heat. So what are conductors? Conductors are basically materials that allow heat to pass through them easily. Basically, they are like they pass heat easily. No, not like the insulators of heat or bad conductors of heat, which do not make them pass through them easily. Like if we compare a light, then we have opaque objects and transparent objects. Translucent is somewhat in between of them. Opaque is like it does not allow light to pass through it, but transparent objects like glass helps the light to pass through it. Same way we have heat things. So let's look at the examples. The examples of good conductors of heat are iron, copper, silver, aluminium. And we can say most metals are good conductors of heat. And for insulators of heat or bad conductors of heat, we have wood, plastic, glass, wool fibers, jute, sawdust. And most liquids are bad conductors of heat. But we have an exception. That is mercury. So what is mercury is basically it's a metal that is at the liquid state in room temperature. And all gases are bad conductors of heat, including air. Now, let us learn about use of good conductors. So first of all, why is there a need of good conductors? So that question arises in my mind. So obviously, The answer of this is because we in some cases where we need to the heat to be conducted through them easily, means pass through them easily. For such activities we need good conductors. So we have a best example, that is cooking. So obviously for cooking we need to heat the food. Obviously we have to mix the spices and all. So these bases cooking utensils are made up of metals, and the metals are most metals are good conductors of heat. So basically that reduces our cooking time and saves our time. But these handles of cooking utensils are made up of bad conductors of heat, so it will not get heated, and we can cook the food very easily. Now let's look at the bad conductors of heat. Now same question, why is there a need? Because we need it because in activities which do not allow heat to be conducted through them easily, where we do not want the transferation of heat from a hotter end to a colder end. Mostly in the cases of ice, we use jute or sawdust, which helps in the prevention of ice melting. Like when we cover it with a jute bag, this prevent ice from melting. Okay, we have one more example, wool fibers. Or so what happens is basically wool fiber is a bad conductor of heat, and there are some spaces in between them, and these get filled with air, which is also a bad conductor of heat, as I told you before. So both these perform in prevention of losing of body heat from your body. So that's why these bad conductors of heat are important. Now let us look at the one more method of transfer of heat, that is convection. So what is convection? Convection is the process of transfer of heat in which heated molecules of a liquid or a gas themselves move to carry hot to a cold region. So obviously I told you before the same property is used in the different methods of transfer of heat. So but the specialty of this or uniqueness of this transfer of method of transfer of heat is that it occurs in liquid or gas molecules, and they themselves move to carry heat from hot to cold region. So a question arises, can convection takes place in solids, and why? Okay, so there's a simple reason that why can convection not take place in solids. This is because the molecules of solids are tightly packed. But if we compare to liquid or gas, they are loosely packed, and in gases, they are not at all bound at each other. So obviously they themselves move to carry, right? So obviously it would be easy for liquids or gases to move to carry hot to cold region, but they are tightly packed in solids, so it's not possible to take convection in solids. Okay, so now let's see convection in water. So there are convection happening in water as well as gas. So let's see convection happening in water with the help of an example given below. So take a beaker filled with some water and then put a potassium permanganate crystal. Its chemical formula is KMnO4. Okay. Now pour some more water. Obviously the crystal will start dissolving in it, and it will start coloring the water. And you can start now heat the beaker. So what will happen is basically the water near the source of heat will rise up, and then after rising up, I mean when they are rising up, they will strike other molecules that comes in their way, and they will also become hot. And obviously if they become hot, they will go up. After going up, they are very away from the source of heat now, so they will come back again and strike other and then rise up and strike other molecules in their way, and the same process keep happening until the heat is being supplied to the beaker. Okay, and this constant movement of water in this case is called convection currents. So basically we can say the when molecules of gas or liquid themselves move to carry, we can say it is convection currents. So now let's see it in the gas. So let's understand it with the help of an example. So take a rectangular box and put two holes in it and place glass tubes. Okay, and it will act as a chimney to the rectangular box. And now put smoldering paper, which basically burns for a long time. That's why it is known as smoldering paper. The specialty of smoldering paper, it burns for a long time. So now when it starts burning, the smoke will enters through the chimney over here, and place a candle below the other chimney, so that the smoke gets heated, and it will starts rising up and increase in the volume, see, and it will get out of the other chimney, and this process keep happening until smoldering paper is burning. Okay, let's move on to the next thing. So now sea and land breezes. Sea and land breezes are actually convection currents. Let me explain. Sea actually have the higher heat capacity than land. So what happens is basic. That means that sea takes a long time to get heated, and it will take a long time to come to cool as compared to land. So what happens, let's compare to day first. So what happens is basically land gets heated up faster than the water because it have the higher heat capacity, that's why. So it will rise up because if it heats up, so obviously the warm air above it will rise up, so there would be an empty space over here, and then the wind of sea will come here, and this is all we know as sea breeze. You can say it is sea breeze. This is in case of day. Now let's look at a night. What happens? So obviously land gets cooled very faster, faster than as compared to water. So the water is warm then. So what happens is basically warm water above the sea rises up, and the same land winds on the land will come to take its position. So land breeze occurs over here. We can say a land breeze occurs in the night, and a sea breeze occurs in the day. Okay, let's move on. Now, applications of convection. So this in the first picture you can see a ventilator attached to high up on the walls. This was used to do, people used to do this in the ancient times. Now what happens is basically the air we exhale is warmer as compared to other gases. So obviously the warmer air will rise up and goes out through the ventilators, and the colder winds or fresh air, we can say, colder fresh air will come down. This is one of the examples of convection in real life. And there's one more thing, central heating. So basically what happens is water or oil is heated in a beaker, and it will form a gas, and it is circulated in the rooms through these pipes. They will circulate it to the rooms. Now let us learn about radiation. So what is radiation? Radiation is a method of transfer of heat where heat can be transferred without a medium. All the that we have studied before, conduction, convection, all they need medium. But radiation, that method can take place whether a medium is present or not, and the energy transferred is called radiant energy. I'll give an example in the real life. So the sun rays that we receive on earth from the sun, basically the space is made up of vacuum, so there's no medium between, so that sun rays are coming to the earth through a process called radiation. One more example I have. So like when you sit beside the fire, the warmth reaches you, right? That warmth reaches you by radiation. How? I'll explain. Because there's no solid and there's a medium between, that is air. First of all, that is not a solid medium. Plus air is a bad conductor of heat. So the heat is not reaching you by conduction. Now convection, in which that air rises up like this. Air rises up. So basically you're sitting beside, right? So it is not reaching you by convection as well. So it is reaching you with the help of radiation. Okay. So conduction and convection required mediums but not radiation. Now, absorption of radiant energy. You might be thinking that there's a specialty in this radiation case, because in that here not all energy is absorbed. Basically, some of it is reflected as well, and it is also maybe transmitted. It is same case as the light, because in some cases light is absorbed, in some cases it is reflected as well, and in some cases it can also be passed through like glass and all. Okay. Now, dark colored objects absorb it is observe nahi? Absorb. Okay. Absorb more heat than light colored. Yes, this is true. I'll explain you with the help of an example that is given below. Take two cans filled with some water and put a lid, and there must be a hole for the thermometers to be put like this, and then the sunlight, keep it in sunlight for some time. Now you might have some questions. Why is there water in it? So that we can measure the temperature of that can, and the water's temperature we can guess that we can get that which have absorbed heat more. And why there's a lid? There's one more property of dark colored objects, that is they cool down very easily if in case they are put in shade. So obviously we want to prove that experiment. That's why we will put lid so that it doesn't cool down, and we have done the same to over here. Now I have a question for you guys. Which of these two will you prefer to wear in summers? This light colored one or dark colored one? The correct answer would be this one. Why? The same reason I have told you here. The light colored objects basically absorb less heat as compared to dark colored objects. So you will feel a little cooler in light colored clothes like this one, but not in this. This absorb more heat and will make you feel hot. Now there's one more example. Can you if you compare an example of electric heater, so what happens is that heating element that heats uh, is that heat reaches us by the reflection process. The polished metal surface is made up of the objects that the substance that reflects the radiant energy, because so that it can um, so that the heat can reach us. If it is absorbed, then how will it reach? The same way. And now the example of cooking base again. The cooking bases are normally colored black. The dark colored ones are there, because so that the heat is absorbed more and the cooking time is less. Okay. Now let's understand the thermos flask. So what is a thermos flask first? It's a household item that is used to keep things warm or cold for a long time. So the way you keep it would be remained for that for a long time. So obviously the insulators would be there so that the transfer of heat doesn't happen. If you might be thinking this is hot than the surroundings, so obviously if the transfer of heat will occur, then hot to cold, so this will become cold, and this vice versa thing. So basically they are made of insulators so that the loss of heat doesn't happen. Or the if it is this is hot and this is cold, and the same transfer of heat doesn't happen. That's why it is made up of insulating material. So first insulating material, that is vacuum. So obviously vacuum is made up of nothing. There obviously there's nothing over here. So there's a no medium also. So conduction and convection will not happen. And as you can see, this thing, it is made up of silvered color, so that the radiation doesn't happen and it reflects back. That's why. And there are cork supports over here, because so that it doesn't break, so that it gets a support to the a glass vessel over here, and it remains prevention of breaking. And that was it for the video. Please do subscribe to my channel and like. Bye bye.